Welcome back to Math Defined. I'm Mrs. C. Today we're unlocking the mystery of proportional relationships. What does it mean for two ratios to be proportional? And how can we check? Stick around and I'll show you two simple strategies to figure it out. A proportional relationship means that two ratios are equivalent. They represent the same relationship between numbers. There are two ways to check. One way is to simplify both ratios to see if they are equal, and a second way is to use the cross products property. Let's break these down with some examples. Let's check to see whether these two ratios, 1 to 3 and 7 to 21, are proportional by simplifying them. We will write them as fractions first. 1 to 3 becomes 1/3, and 7 to 21 becomes 7/21. Now we simplify. The first ratio, 1/3, is already in simplest form, but we can simplify 7/21 by dividing both the numerator and denominator by 7, which gives us 1/3. Since both ratios simplify to 1/3, they are proportional. Now let's check another pair of ratios using the cross products property. We'll compare 1 to 5 and 6 to 30. The cross products property states that if the cross products are equal, then the ratios are proportional. We'll need to write these ratios as fractions first, 1/5 and 6/30. To find the cross products, we multiply diagonally. We'll multiply 30 times 1 first. 30 times 1 is 30. Then we'll multiply 5 times 6, which is 30. Since both cross products equal 30, the ratios are proportional. So far, we've checked proportionality using two ratios. But what if we have a whole table of ratios like this one? How can we tell if x and y are proportional? We can use our two strategies, simplifying the ratios and cross products. But first, we need to find the ratios in the table. The table is comparing x to y. So the first ratio in the table is 2/4. Let's simplify it by dividing both the numerator and denominator by 2, resulting in 1/2. If x and y are proportional, all the x to y ratios in the table will simplify to 1/2. So we need to simplify another ratio from the table to check. It doesn't matter which one we choose. I'm choosing 4/2. We can simplify this fraction by dividing the numerator and denominator by 2, resulting in 2/1, or just 2. Since the simplified ratios are not the same, x and y are not proportional. To confirm, we'll use cross products. Again, we can choose any two ratios from the table. I like to pick ones with easy numbers, so I'll choose 4/2 and 6/1. To find the cross products, we'll multiply 1 times 4 to get 4, and then 2 times 6 to get 12. And obviously, 4 does not equal 12. We have confirmed again that x and y are not proportional in this table. Now let's look at a table where x and y are proportional and check using both strategies. Hopefully this will give you an opportunity to see which ones work best for you, keeping in mind that the strategy you use will most likely depend on the numbers in the table. For example, the ratio numbers in this table are very easy to work with. Which method would you choose? Let's start by simplifying the ratios. The first ratio in the table is 1/2, and it is already in simplest form. For x and y to be proportional, all the ratios in this table must simplify to 1/2. Let's check the second ratio, 2/4. 2 is half of 4, so 2/4 simplifies to 1/2. So far, it looks as if x and y are proportional, but we need to check at least one more ratio. Let's look at the last ratio, 4/8. Again, 4 is half of 8, so 4/8 simplifies to 1/2. We can feel confident now that x and y are proportional. Now let's verify using cross products. Let's compare 2/4 to 3/6. First, we multiply 6 times 2 to get 12, and then 4 times 3 to get 12. Since the cross products are equal, x and y are proportional. Keep in mind that if we had used just the cross products property to check for proportionality, we would need to check a couple more ratios to be sure. This time the table is vertical instead of horizontal. Can you figure out if x and y are proportional? Before you begin, make sure that you identify how the ratios are written. Remember, the table is comparing x to y. Okay, first we'll use simplifying the ratio strategy. We'll simplify 2 to 12. Dividing the numerator and denominator by 2, we get 1/6, which I see is also in the table. Now, to be sure that all the x to y ratios in this table are proportional, we need to check a few more. But simplifying a ratio like 1/2 to 3 isn't so easy, so let's use cross products. We'll check to see if 1/2 over 3 is equivalent to 2/12. First, we'll multiply 12 times 1/2. We could write out this multiplication problem, but let's use some mental math instead. What is half of 12? 6. And then 3 times 2 is also 6. Since the cross products are equal, the ratios are proportional. Using a combination of simplifying ratios and the cross products property, we are able to confirm that x and y are proportional in this table. Let's test one more table, but this time the numbers don't look very easy to work with. But we have 2 different strategies that we can use to determine whether x and y are proportional. We could simplify the ratios, but since the numbers are a mix of whole numbers and fractions, that's a sign that using cross products might be the better choice. Let's check 1 to 3/5 and 4/3 to 1/2. We'll multiply 1/2 times 1 first. That's pretty easy because anything times 1 is itself, so 1/2 times 1 is 1/2. Then we'll multiply 3/5 and 4/3. 3/5 times 4/3 equals 12/15, which we can simplify to 4/5. Since 1/2 is not equal to 4/5, x and y are not proportional. And since this first pair of ratios that we chose to check were not proportional, it is not necessary to check anymore. And that's it. We explored 2 simple ways to check for proportional relationships: simplifying ratios and using the cross products property. Which method did you find easier? Let me know in the comments. Thanks for watching, and until next time, keep math awesome.